welcome to reInvent. Are you awake now? Who here has had the problem where they've submitted a ticket and had the frustrating experience of it not working exactly how you expect? That's what we're here to talk about and how generative AI can help this process. My name is Kim Robbins. I'm a senior AI strategist from the Generative AI Innovation Center. And with me, I brought Oscar, a senior applied scientist, also from the Generative AI Innovation Center, and Jens, chief cloud architect from BMW. The Generative AI Innovation Center has been working with BMW intensively over the last two or so years, working with BMW on their adoption of generative AI. And BMW has a long history of being a very innovative company, and this is no different with their approach to generative AI. Now I'm going to hand over to Jens to talk a little bit more about BMW.
Yeah, thanks for having us. Since we're talking about ticketing, what we would like to start is the content about the domain which we talk about. And this is like the BMW has the aim, the target, to provide premium experiences. With driving, that's kind of easy. I mean, if you drive one of our vehicles, you'll know the difference. For digital services, that's a little bit more difficult. I mean, you guys all know probably the well-architectured framework and that stuff. I mean, but that's a must. I mean, a service and all that stuff, it has to be available. That is really not something to distinguish yourselves. What I'd like to do on this slide is to show how we try to build premium digital services by a combination of several services. And I will give you some examples because you will see this is the stuff we develop and this is where the tickets will generate it. So let me just start with one example. We regard a service as premium if it is connected. By connected means that the vehicle interacts with the cloud to provide a better experience than the vehicle by itself. And just to give you like maybe one small KPI, we got 23 million fully connected vehicles, and on a daily basis, our backend hosted on AWS processes 14 billion requests. So connected would in that case be an example that we show the driver traffic information, real-time traffic information. For instance, if you drive here, it should show you the street with less traffic. That's an example for connected, that we get data from the backend to augment a function in the vehicle. Smart is the next example. And this is also kind of a anniversary because I think almost 10 years ago, we were here at the reInvent, I think the first time, and we showed a service which we called local hazard preview warning. And this is an example of a smart service because it should just show you at the right time when a hazard is somewhere ahead. Yeah? So again, feature inside the vehicle, sends data into the backend, it's augmented, and then put back to the driver to tell him, hey, there is maybe fog or some stuff. This is also another example for assisted, where we have a lot of features which should help you make driving more convenient, more experienced. I mean, especially one example is our Autobahn pilot. So in countries where you can speed a lot on the highways, this is like a nice service because it helps you to overturn safely. Integrated is an example we showed also last year at the reInvent, is that we try to integrate our vehicles into the digital ecosystem of people. For instance, your Spotify account, or as you can see on that picture, in our 7 Series, where we're the only OEM who offers Amazon Fire TV in the back of the vehicle. Then the last one I'd like to mention is the upgradables, that we are capable, and we do this for more than 9 million vehicles, that if you buy a vehicle from BMW, it will get continuous updates with new features and all that stuff. Like, for instance, also the AI-based functions we have. So all the stuff you see, so if we put all these criteria together, this is what we regard as a premium service, as a digital premium service. And the key to all of this is software inside the vehicle and hosted on the cloud. And this is the software where we talk about the ticketing. And just to give you like a little bit of some KPIs, some insight about the experience BMW has with software. And so if you drive one of our vehicles, and I hope a lot of you will do, We have been developing software in-house at BMW for more than 40 years. Yeah? I mean, of course, not in the extent we're currently doing, but still, driving assistant, injection, and powertrain, all that stuff. So 40 years of in-house software development. At the moment, we are roughly 12,000 internal developers doing 140,000 daily builds. And on average, the software gets into 5 new vehicles a year, but also, I mentioned the upgradability of our vehicles, it gets into the vehicle you already bought. So this is the stuff we talk about. In this stuff, let me just show you how tickets are created in our domain. And we focus not on powertrain or driving assistant, but we focus where a lot of tickets are created, it's the infotainment. So what you can experience if you drive a BMW, all the entertainment, music, and all that stuff. So what it is basically is like a big funnel. And the idea is the further left we are, the more it is fully scalable and fully automatable. So our developers, the 12,000 people, what they do is they start developing and testing the software, kind of trivial, like everyone does, with unit and integration tests as part of the CI/CD. Then we got something called software in the loop, which is for some of the gamers here, if you ever tried out a Super Nintendo or something on your PC, that's basically the principle we have. So we're capable of emulating the full software stack inside a PC or an EC2 unit in the cloud. So if these tests all pass, and these tests are highly automatable, we go the first time into the full component. And something which we are really, really, really proud of is our head unit in the cloud. That is, together with AWS, and we presented this last year here at reInvent, we are capable, and I think we were the first to the best of my knowledge, to use an EC2 instance as to run an Android-based control unit natively in the cloud as a native development target, which also helps us to scale the development. And if these tests work, we go the first time into the full hardware. And you can see on that picture, that's how an infotainment device looks like, with lots of cable and all that other stuff. Now, if that works, and all these tests are passed, we go in the first time in the subsystem. That means it's an end-to-end test environment. That is, the infotainment system which interacts with the cloud and also in and output, especially this is the first time where we can really test if the sound works or if like speech commands to the vehicle work. And if all these subsystems work, we test the full cluster. That is, like you as a driver would see the whole infotainment, including steering over the wheel, also like the combi and other stuff. And if these tests work, then we go into the vehicle. And as you can see, this whole funnel on the left side, fully automatable, highly scalable, and on the right side, it's not really scalable because you're inside a vehicle. And why did we show you this? Because every time one of our developers, testers, or people involved sees something which he or she regards as a bug or a failure, or which just is not too high up to the standard you as a customer would expect from us, he or she issues a ticket. So this is where the most tickets about which we talk are generated. And as Kim asked at the beginning, you all know the problems about some tickets. And we will just walk you a little bit through some of the problems. First, tickets can have inconsistent quality. You just saw the funnel. Software developer has a totally different insight into the component or into the software as one guy who would test it in a vehicle. And this is already like a good example why you can have gaps in the ticketing. And the other thing is, who would be responsible? If I find a ticket, is it the function I saw which caused the error, or is it like another function? And that I hand over to Kim.
And also there's the hidden dependencies. So I think we all see in an enterprise environment, there's like a lot of other data sources and maybe dependencies of why there's an error. And so we wanted to be able to think about like how can we unlock those to make ticket resolution a little bit faster. And of course, the worst problem of all is duplicates. I think there's nothing more frustrating than having to do the same piece of work a second or third or fourth time because it comes up in your ticketing system and wasn't identified as a duplicate earlier in the process. And now we really thought through what does this journey look like from a user, and we really split this into two areas. So on the one side we have the ticket creation process. For example, I know that recently I had a very detailed ticket I had to do as part of my day job, and I came across 5 times I had to go through the process of trying to submit the ticket because I had to find information from different systems, and then it wasn't meeting the data quality standards. And so we're really trying to think about how can we make the process better from the person that creates the ticket, and making sure that we can accelerate the resolution process. But there's also the other part, which is the ticket routing and the process that happens once the ticket is submitted. Not just the developers that are working on it in the end, but how do we route it to the right team, make sure that it's got the right information, that we can improve the information. There's definitely, as Jens mentioned, a lot of disparity between the information the person that creates the ticket puts in versus what the developer may need to get the right output. And so we're really trying to think through of what does it look like from a normal ticket and how do we make that better. And so we thought, can we add something around a summary of the ticket and the available data to make sure that we can surface better and more concise information from all the information that's put into the ticket and the information that's laying across the wider ecosystem that we can surface. There's also making sure that there's a high ticket quality, as well as making sure that the necessary information is automatically completed. I think we all have the experience where you have to click through and add extra information from drop-down boxes and try to work out which team this has to go to, or what area or division or problem that you're trying to solve. And so can we surface that and make that a little bit more completed in a more automatic fashion? And lastly, adding additional context from the other data sources that are often hidden from the ticketing system. So in the case of BMW, this is potentially log data, it's maybe documentation on their code, and also having code analysis to sort of surface and add context and useful information for the developers who eventually get the ticket in the end. And so we worked backwards with BMW to really understand the 4 pillars that were the priorities of BMW to solve. And so the first one is obviously everyone would like to have better, improved ticket quality. I think this is something that's common for all enterprises. The next one is, and this was really the key one for BMW, was detecting duplicates to reduce the duplication of work for developers and making sure that they're not wasting their time doing the same work over and over again. So we really wanted to, as a first step, solve that problem in the ticketing process. Of course, as we mentioned, we want to uncover additional insights and really understand, from root cause analysis and logs and other tickets, historical and so forth, what additional context we can add. And then, of course, routing the team to the right ticket, routing the ticket to the right team and making sure that it's going the right place. And I think we've all seen the time that you've put a ticket in and it's been sent to the wrong team, and it takes a day to eventually get to the right team, or you have to follow it up. And this is frustrating both, I think, for the people that create the tickets and people that are processing, and then eventually the people that resolve the tickets. So we tried to build a generative AI companion that can go along this process from once we take the ticket from the ticket creator or the test driver in this case, and then being able to surface both and use the historical ticket data that BMW has, which is several years of ticket data, which is actually over a long time adds up to quite a lot of tickets and can be quite useful because a large language model can pass all of that information. And also having a good understanding of the current state of duplicate tickets. So matching both the historical trends and tickets as well as the current known duplicates to better understand, is this already a duplicate and how does it relate to historical problems that we've already solved? And then, of course, moving along the chain to enhancing the ticket. Eventually, from that point, we can take a large language model and take all of the data that we've gathered so far and make a recommendation to route the ticket correctly, and also add a summary and potentially add the additional context that is missing. And if you think about the routing process, or the person that is routing the ticket, normally they're working down the knowledge step by step and going deeper into the data. And with generative AI, we can feed all of the data into it and then make a much more concise recommendation that the person can then read through what tickets is it related to and where does that go next. And I'm going to hand over to Oscar now to talk about the solution that we built.
Yeah, thank you, Kim. Thank you, Jens, also. So what I want to do is I want to talk a bit through the solution that we built for this first proof of concept, so this POC, where our goal was to identify duplicate tickets and bring those to the users so they can make better decisions. Is this a duplicate? What do I need to do with the ticket that I have at the moment? So let's get started with this architecture overview, and there's a lot to see here. But I want to go through this step by step to sort of give you an idea of how you can think of a solution like that. So we can really split this into two components. The first being the data ingestion. So this is all you see in the top 2/3 of this architecture. And this was really crucial for this proof of concept, that we brought in the data that was there historical tickets, into the system. So what we did here is we started by just extracting the tickets and putting them into an S3 bucket. So we started off there. Then the first step, we removed all PII data from the ticket, so any personal identifiable information. And we did that using Amazon Comprehend just to redact all that information. At the next step, we went in and we enriched those tickets. So we brought them into a format that we wanted to use throughout this process. And we did that using Anthropic Claude 3.5 from Amazon Bedrock. At the next step, we started ingesting those tickets into our database. And we did a couple of things here, but the first step is really going in and creating then an embedding of that component. So we have a vector representation of that ticket, and we bring that into our OpenSearch index. So this is really the component of bringing in data, and I think this might remind you of something you have seen a couple of times in the last days or in the last year. Right? This is very similar to what you would do in a traditional RAG framework. Right? So this is like to set up a RAG, so retrieval augmented generation framework. Also, what you want to do is you want to ingest your data into the system somehow. There's a different components to this here, but the underlying architecture actually looks very similar to what you would do at those points, right? And I think that's like a key learning also, like how can we use those concepts that we see in other places for other use cases, and how can we recreate those frameworks and recreate that architecture that is very well tested already to bring in new solutions. So now we're at the stage where we have all the tickets, the historical tickets ingested into our database and can find them. So now we go to the second part, which is retrieving those tickets, and this is much closer to sort of what you would see in a production setting. And this is the bottom part of this component, which is the search. So what we would do here is, right, we have a new incoming ticket. So this is here, this one new ticket that comes in, and the user does this, and then we have a person who needs to do the routing, needs to identify what we need to do. So what we do is, again, we with the Lambda function, we create a enriched version of that ticket. So we create a better summary of what is really in the ticket. We might add information that needs to come from other sources. And then we also create a vector embedding of that information and search against that in our data store. We do a hybrid search. There's more components to it, and we'll go through that in detail in the next slides to retrieve the first components, and then we classify in a way whether the tickets we've retrieved are duplicates to the ticket we have available for us. So this is this broad overview of what the architecture looks like, and what we'll do now is go into details what that solution looks like step by step as we look at sort of the production side of that. So what happens to a new ticket? What is sort of the flow as we identify that ticket, and what do we do? So there, in all 4 different stages, and we will, after the slide, go into each detail. But this is really to give you an orientation of what we will talk about at the next couple of slides. So the first thing we do, right, is the ticket comes in and we do enrichment of the ticket. And we use an LLM. In our case, we use Claude Sonnet 3.5, but you could use many different LLMs at this point. Then what we do is we go to this finding duplicates, so this retrieval step, if you want, where we go to our OpenSearch cluster and do a hybrid search to find the first couple of duplicates. And this is really the step, right, that Kim mentioned, where we go down and we're able to actually surface all that information that is out there and just narrow it down to the information that is necessary for this one ticket. So at this first point, this is really focused at other tickets that we find. So we surface 10 candidates at this point. But you could think further here, and we will do that as we go, that you could say, right, any other information that might be relevant here could be surfaced from other data sources. So that could be documentation about the process, that could be other relevant information that you want to have that helps in the end to make the decision, right, either where do I route this ticket, how do I solve that ticket, just to really help add information that you need at this point. So this is the second step, right, where we retrieve extra information, in our case, the first duplicates. And then comes sort of the next crucial step where we, again, go back to an LM and say, right, we now have these pairs, this is the new ticket, and these are all these candidates. Can you go in and explain to us, is this a duplicate or not? So we have a classification step where we compare them, and we ask the model to classify, is this a duplicate, yes or no? So, right, this is sort of, if you want to bring it down to what the task is, but we add, crucially, sort of a thought or an explanation step where we don't just say, right, is this a duplicate, yes, no, but we go further and say, okay, why is this not a duplicate, or why is this a duplicate, right, to really point the end users to that information so they can make a well-informed decision. And then I think, and this is a very important step here, at the end, the decision lies with the humans, right? At the end, we'll have someone who makes a decision, is this the duplicate here? At a later stage, where do I route this ticket? And this is really then, if you think of like all that information that we had available, right, at this retrieval step, it's all the information that's out there. We bring that down, then through enriching that further and throwing out some parts by the LLM, we bring it down even further, and then all we are left with is maybe 2-3 candidates that we need to show and the person needs to look at to make a good decision. Right? And I think this is something that hopefully all of you can relate to, that it's really hard to say, okay, there's a duplicate out there if you have to look for all the tickets that are there. But if you would be tasked, right, look at 2 tickets and say, right, is this a duplicate for that? That is a task that you can do very quickly and very easily. So this process really brings down that effort to it. So we'll now go through this step by step. And I'll first hand over to Jens to go through the first part again.
Yeah, thanks a lot, Oscar. So, I mean, Oscar just basically walked you through. What we will do now is go into each detail. And the first step was enriching tickets. And this is by itself already really valuable. Because basically, as we said before, depending on where in our whole workflow chain this ticket could have arisen, it might have a lot of information or even lacking so. The first what we do is we pass the whole ticket and try to create a summary of the ticket. So which helps it at one short glance to identify what is really the ticket all about. While we're doing this, we're also going and trying to eliminate acronyms, because it's not really 100% sure that some other guy who reads that ticket knows what this acronym is all about. And we also try to reduce redundancies in the ticket. That is, if some people write the same stuff several times, we just try to identify and remove this. And this worked pretty well already with our LLM. And then we went for another step and we said, hey, given that, and this also applies to all of you companies, most of the companies are multinational. That is, it's not 100% sure that everyone writes the ticket in English, for instance. I mean, in our case, we got production facilities across the world. We got in China, we got all across Germany, we got in the US and all that stuff. So this already helps us to translate all this stuff so that other people who might not be capable of that language can get a grasp what the ticket is all about. And while we're also doing the enriching of the tickets, a really, really important step is the consistency of the data. This is something we want to increase. So, as said, we get a ticket. You can see here the kind of prompt we have, and with the prompt, we walk over the whole ticket and put it into a better quality, which is already, as Kim will show later, already of high value. Now, the next step is the core of it all, because the focus was from the beginning, can we identify duplicates? And what we do is we do a customized high-rich search. I will walk you through the first part. Oscar will show you the second. We start with a really simple one, just as you could do without LLM and all the other stuff, just a keyword search. For instance, which embedded device is relevant for that? Who did this? Is it something during a specific test? And this is really nothing fancy, nothing special. Something you could already do, as I said. we're having a look for traditional words we search inside the ticket. You can see here an example.
And then we combine that with sort of the now available components of adding semantic vectors to that component. And this is sort of visualized here, right? That we take this entire ticket, this entire box, and put that into and create a vector to search with that vector semantically. And I want to go into detail here. While you might have heard that before, I think it's really important to grasp these concepts and go through that. So I want to talk a bit about what is an embedding vector, how does that work, and why is that relevant for all of you to find information. So the first question is, right, what is a vector? What is an embedding vector? So that really is a numeric representation of a word or a sentence. So you could say, right, you have a word or you have a sentence or even a long text, and you create one vector, so a list of numbers, essentially, that represent that word semantically. So what that means is that similar words in semantic meaning will be mapped to similar spaces in that, so the vectors will be very similar. And that is something that has been available for quite some time, but really focused on small words or maybe small sentences. Now we can do that for larger sentences. And what these are being used for is often for classification, similarity search. So these components is something that people have been working on before. Once you have like a vector representation of something, this can be a word, this can be something completely different. This is really the basis for tasks like classification, similarity search, or other tasks in that direction. So how does that work, right? I've already talked about a vector is a semantic representation of that thing, and it's high dimensional. So this is, right, I can, on the slide sort of try to show you 5 dimensions here or 6 dimensions, but right, we sort of limit to that. But really think huge, right? This is large dimensions. With the current versions, we go from 200 dimensions to 1,000 dimensions of vectors. That means you have 1,000 components to these vectors, right? So this is 1,000 directions in which these point. And what you will have is that similar meaning will point in similar directions. So these will be points in that space. And as sort of visualized here is that similar meaning, right, gets clustered in these similar areas. So you'll have like an area that represents, defects with in our case with the infotainment component, maybe with other components, they will be mapped in other areas. So this is something that you can use in any case. And what you then do is, right, you now have a new vector, you have a new ticket that you bring in, you create that vector representation, you sort of put that in that space, and this is literally what you do, right? You put it in there, and you look around what are the closest neighbors to this ticket. So what is closest in meaning? And then you do a measure of similarity. There's different ways of doing that, but it doesn't really matter too much to go into these details. It really is about, find the things that are closest in this space. And then you take those and you take the first 10 and bring those out. And this really helps you to go out and, from all these points that are in this gigantic space and bring out the 10 closest points, the most relevant things we have. So this is what we combine with this structured search that we had before. So now we have these 2 searches that bring in tickets to us that become relevant. We add this together, and then we add another stage of filtering those tickets based on time, based on software versions. And this is really, again, standard SQL-based filtering that you probably all have been doing or could have done all these last years. So what we've done now is, right, we've gone from the first ticket that came in, we've created the more enriched version, we've used that enriched version to find other tickets in our space, and now we want to go in and narrow that down even further. And this is the step where we say, okay, we go back to the LLM, right? We go back to Bedrock and say, here we are, these 2 tickets, and we do this for all these pairs, and we create a prompt that sort of, in nicer words, says, please look at these 2 tickets, compare them, and tell me if these are duplicates. And what we do is we ask them all to compare the tickets, right? Pointed specifically to look at times, look at software versions, understand what is the root cause behind it, and explain what you need to do. So what this does, it will narrow down these number of duplicates even further, and it will make the decision in the end easier. So here's an example of what this might look like, and this can look maybe a bit this is not like a real ticket, but this is very representative of what we have. What we actually see here, we have 2 tickets. And there, maybe you realize this, in 2 different languages. First is English, the second is German. And they're sort of structured differently, but there's key parts that are very similar. For example, the timing is similar. So this is shown in green here. You already have this sort of mix-up, right? Like, how do you write time? There's like, what is the order of year, day, and month? But it is the same, right? The same day that we're looking at here. And then we also have the software version that is similar. And then this is really what the model helps us to do, right? If you would look at these 2 tickets here, at the first glance, very hard to tell, is this the same? You first need to find, what is even written here, like where is that information? And the model can really help you do that. So the model would here come out with first saying, right, my decision for this is, yes, this is a duplicate. And then it will give you a reasoning of what it's looking for, right? It will go through, right? The description is very similar. It sees a similar problem. And then there's other key parts that are there. This is the same software and a very similar date that we see. So this, right, is key information that will help you identify what you want to look for in these next steps. And then we have that, right, for a smaller set of tickets, and we go ahead and we give that to the human for the final decision. And that will be my friend Jens who will take that.
Thanks. And I mean, the real technical challenge was the slide Oscar showed. But this is really also a really important step, the human decision. Because what we do now here is we give a human and say, hey, we think, or the model thinks that these are duplicates. Can you confirm or not? Why are we doing this? I mean, it's the same with ChatGPT. It really took off when they introduced RLHF, that is reinforcement learning from human feedback. And this has like 2 big advantages for us. The first is we learn, we give the model feedback what could be a duplicate or not. And Oscar will show you on a later slide how with that step we can make like a flywheel. And a flywheel has the big advantage that you can scale. The whole process has the target that we can scale our ticketing. So this feedback gets the model better on a continuous way, and it helps us, or it helps also the developer to have a look and really learn what the system can, and to improve the system continuously. Yeah. So after we walked you through the whole steps, what were the results? I mean, I said from the beginning, the summary we wrote is like something which a model can basically do quite easily. But this already gave good feedback that people said, hey, that's really great how you can get all the data and still do a summary. But the real benefits for us, the real advantages it helps us to route tickets way more precise than before. That is to the right person and not the person who some dude who issued the ticket thought was the relevant guy. We increased transparency because we have full transparency with all the tickets. We see what is happening and can really, on a continuous basis, also evaluate how many tickets were processed and all that stuff and how many duplicates. But by far the most important thing it does is it reduces the load on the developer. Because if you develop software, you know how it's happening on a daily basis. Ticket. You have to spend 5 minutes maybe to check a ticket. And then if you have just 10 tickets a day, it's 1 hour. It's 1 hour of waste we can reduce by just doing this, by just using an LLM to improve the whole workflow. All right, I hand over to Kim.
Thank you. So we had some lessons that we learned through this entire process, and I think the first one is that generative AI does add value, but one thing that we found was really important for us is to, and for BMW as well, is to have a value-added approach and really think backwards of like what is the business value that we're trying to achieve, and how can we measure and pick outcomes that can really help the process along. Also, we found that like choosing the right subject matter experts. So we really went deep with people that were creating tickets, also the people that were processing the tickets, and of course the business owners of the entire ticketing process that have the KPIs and the responsibility. And by having all the different subject matter experts, we were really able to understand the problem in a way that we could then work out the best way to apply generative AI. And I think maybe like one framework that we've talked about before is that sometimes a LLM is a little bit like an intern. So you really need to understand the process really well so you can teach the large language model how to add value. And of course, the last one is investing in people that can bring both the technical understanding of AI, but also the key business domain knowledge. Now, we would like to talk a little bit about like the reinforcement approach that we had. So if we start from the ticket routing, which was where we started at the beginning, and then we get to having the ticket resolution, and then this feeds back into the ticket database. And by having this flywheel going around, we end up with higher quality data. We also end up with finding the right team faster and more accurately, which results in a faster resolution and less duplication and work for the developers. But there's one more thing that I would like to add, and I'm going to hand over to Oscar to go a little bit deeper on that.
Yeah, thank you, Kim. So this is something that Jens already hinted at is, right, whenever we have this human decision at the end, what we do, right, through this usage, we label data. And I think that is really something that, right, very valid for this use case, but this will be valid for all your use cases that you have out there, right? Once you get interaction with your models, you can collect that data and see, what happens, what questions do your customers ask, what problems are out there, and what is the information that helps them solve that problem. So what does this mean for us, right? Like whenever we have two pairs of tickets, right, we identify, right, we get a positive reaction like, yes, this is actually a duplicate. We have a labeled pair of, yes, this pair belongs together. This actually belongs together. This could be also similar, right, for other data that we bring in the future when we say there's documentation that is out there. We say, right, this documentation was helpful to solve the problem, right? Like because it was there, the problem was solved quickly. So what this means is, right, there's a great indication that that piece of data and that ticket belong together and that they are close together and they are important pieces of information. So what this means is, right, throughout the process, we keep track of, when is the information we bring in helpful, when is it not, when have we brought in the right ticket. And through that process, right, we add more and more labeled data that we can use at the next step. And what we have, what we can do then is we can fine-tune an embedding model, right? So this is what we talked about earlier, right? This like creating these vector representations, creating this huge space of all the tickets. So what you can do with an embedding model is you can fine-tune also that model, right? You can not just fine-tune a large language model, but you can fine-tune these much smaller embedding models as well. And what you need for that is really these pairs of data, right? You need like positive pairs and say, right, these two pieces of information, those are close together. So what you will do in this process is you will go in this space, so to say, right? And you say, right, these are two pairs of tickets, and I want you to make these be close together in the space because I know they belong together, right? So you go in and you fine-tune the weights in such a way that the new vectors that are represented become closer together in that space. You also add some other, pairs that are actually negative pairs. We say like these do not belong together, but these are very easy to find. It's really hard to find these like good pairs. So once you have that, you bring that together. You bring in your like pairs of data. You add fine-tuning to your base model, and you ingest your knowledge, your information, your process right into this embedding model. And this really helps you to look at that flywheel that we had before and really spin it even faster, right? Because we add another component to it. We add sort of a data flywheel to the whole component. So we already had this process that just helps itself, right? Because the data becomes better. It becomes cleaner, the tickets we have. We just have higher quality data throughout the process. But now we're actually able, through that labeled data, right, to have a better embedding model. So throughout that process, we will have even better tickets that we bring in, right, at the step 2 that we had, right? The things we bring in are even more relevant, are even easier to digest for everyone involved here. So we increase that even further, right? So the results here become even more relevant, and we spin this even further, and we really go out and do this. And I think this is a great take-home message from this alone, right? Like, think about your process and think about like what does usage do for you, and what does this like help you to collect, and what data could you use to improve the process you have, and this can really be sort of on sort of a secondary model that you help find better data in your RAG system, in any other system. So going in and identifying that and collecting that at the right point to bring that into your process and really speed up your flywheel and accelerate your components. So with this, I'll hand back to Kim for the last calls to action.
Yeah, so I think one thing that we have from our experience is involving the right subject matter experts. And something that BMW has been really great with is when they find a problem that they think they can use GenAI for, is just to start and get going with that. And one last thing I would like to add is if you would like to come and speak to the Generative AI Innovation Center, we have a really large area in the Expo Center at the Venetian. Under the AWS, we have a GenAI village, and you can come and speak, and probably you will catch Oscar and myself later today. And with that, I'm going to hand over to Jens to summarize everything.
Yeah, and just I would also mention something. Just as great as this vehicle was the work we did together on this pilot. And as you can see, the real value we got already during the POC. We could see that it has some great impact. But then, as you can see, we also asked the product owner of this stuff how happy he is with that. And yeah, I mean, basically with that, we say thank you for listening to us.